So true. Okay. Cascade probability. Alright, you wanna compute the likelihood. Model, click list. I for U in click list, PA cascade probability, U or B mixed probability, PPA 1 minus PPB, avoidance 9 is 14, else that log mixed probability is log E. The natural logarithm. Actually, I love Python, right? Fuck yeah. That's it. That's what I like about Python. They didn't say log 10, log means log 10. I don't wanna follow the rules too. That's it. I'm nothing less than Python. Uh, it should be size 2 and I don't know. QP. What was P? Take that. For J in range N. So it's a recursive function. What is epsilon? How does that work? Return G. Okay. I don't get it, to be honest. Oh, okay. Okay, update A, false, or update B. Is that true? Why should you do that? Why don't you treat them as two n parameters, Victor? Okay, he's doing it. But okay, the problem is that exactly. Uh, yeah, I don't like this part. Yeah, why are you computing with RA new? I don't like computing it with RA new. Actually, I don't like it. See it? Fucking, if you don't know how it works, ChatGPT can be a piece of shit. By the way, here we didn't need to change anything to one based, by the way. Why? Because we are just doing a maximization. We are okay. Because it is just numerical. We don't care about the formula of the likelihood. So it is a very general gradient updating rule. So we don't care about it. That's really good, actually, better. And especially fuck that. I don't want to care about mathematics. Let's the gradient do the shit. Uh, Instead of cascade probability, I need to use what is the name of it? Right? Instead of that, I need to use that word. Name. No click probability zero base. No, I need to use this one. 0 to n minus 1 exactly. Sounds good. Minus 9. Q is P is 0.6. Q is we should also find Q or no? let's assume we know Q. Click list is also given by click list. Alright, let's run this shit. By the way, what items are in the same group? 0 or 1, 4, 1, 4, 6, 7. 1, 4, 6, 7. 1, 4, 6, 7 will be 0, 3, 5, 6. 0, 3, 5, 6. 0, 3, 5, 6. Ah, we don't have it. 0, 3, 5, 6. 0, 3, 5. Ah, okay, 1. And then I don't want to do this conversion now. And then I want to say click list. Exception. What is that? I don't want to. What is it called? Positions clicked. And then I want to say so likelihood is getting worse. So this last part of the code, let's check it is correct then. That sounds correct. And What is the value of epsilon then? 10 to the minus 5, alright. Why should you do that? Return G to what? G is the gradient, alright. Where is R come? So iteration make it 100. And what is the step size? Why did you choose a step size as 10 to the minus 5? Yes. Where is it? Cascade mixture. How many fucking function? Where do we epsilon. Where is epsilon? Gradient R mixture. Fucking epsilon here. Fucking learning. Okay, we are changing RARB with epsilon. And we change RARB with epsilon 10 to the minus 1, 5, and see how much compute the gradient. Epsilon does. So how is epsilon and learning rate related here? Fuck you! Piece of shit! So how do we do that? We wanna round G round RAI, for example. We compute that. How do we do that? It is almost G of RAI plus epsilon minus G of an RAB and over epsilon I. So we compute that. We can do it. Then what we do is G of, we go in the direction of the so we have a gradient of G, and then the new X or new R, exactly, RA RB new will be RA RB plus learning rate times gradient of G. So I don't think we need to have any connection between epsilon and learning rate. It's fine. I was killing myself for nothing. I don't think we need it. Largely independent. In a finite differential equation is the smallest step used to numeric approximate partial derivative. Notice how far you move in the direction of that gradient. Parameters must be small enough so that they get a good local slope approximation. Inaccurate. Yeah, you want epsilon be smaller than learning rate. Go to the -3. I agree. Let's make it -3 and iteration 100 sounds really good. So you can see that the likelihood is decreasing, and it is decreasing actually. It's not looping. So if I say 1000, what will happen? it's constant. Okay, RA, pretty good. So we had 1, 4, 6, 7. What's that do? I can say it from here. 1, 4. I don't have them here. 1, 4, 6, 7. We have 1, we have 4, we have 6, we have 7, and we have 2, we have 3, we have 5, we have 8, and we have 9. Pretty good. I'm happy. I'm happy. Let's show with it. That's a good deal. So, and you can see that it is decreasing. Not really. It's just became constant after a while, which is good news. All right, let's go over some of the papers we wanted to take a look at. And then what is the next step? What the next step may be saying, what if we don't know P? I don't know what is a good number for having them. Next step. What if P is unknown? And I want to also try it with a wrong P, like say P, where is P? Instead of P, I want to say 0.3. Not 1000 anymore. Fuck it, 1000. Decreasing. Worse than last time, but pretty close. Yeah. But if P is unknown, then we want to say, what if the number of categories are unknown? Alright, let's check out RARB. So 1, 4, 6, 7 actually is okay. 1. This time it's just swapping. RB is the one. RB 1, 4, 6, and 7. So we can see that, and the other one 2, 3, 2, 3 should be 5, 2, 3, 5, 8, and 9. Alright, 9 is terrible. The thing is that we are doing a bad job on 9. We are not doing great on 9. However, quite robust with respect to P. Right? And let's go. Alright, I'm happy with the code at this stage. Let's go over. And I didn't do any math. I don't want to take the derivatives. Fuck that. I asked this question before last session, and yes, CR. That's I use a small r for an index. That was why I couldn't. Okay, these are no. Okay, just let's go over some of the literature. Before that, I wanna listen to some of my voices. Alright, I'm back. Alright, we wanna find train. My laptop down or what's happening? Okay. Train 2009. Alright, we will look it up later. These two papers are first. This is not a paper, this is a learning mixed multinomial logic models. It's a thesis, PhD thesis, yes. From Department of Civil and Environmental Engineering. Multinomial logic models by Yikun Yu to the Center for Computational Science and Engineering. I wish somebody could read it for me. What are the chapters? Yeah. Polynomial learnability of MMNL, introduction, MMNL formulation, multinomial logic and random utility models, mixed multinomial logic, and literature review. And then we have overview, and then we have problem formulation, learnability, identifiability, mathematical and statistical tools, semi-algebraic set, and Tarski theorem, methods of moments, polynomial learnability, the grid search algorithm, MERGE results, provable guarantees, data-driven approach, Folkwang, Frank Wolf, the construction, numerical experiments and cascade studies, Relation of data generation, mixture type recovery, comparison with original algorithm, comparison with EM algorithm. Okay, so learnability of multi-level. We don't like EM because it doesn't do great. Case study, the Nielsen consumer panel data, data curation, experiment setup and results. These are amazing. I like them. List of figures, introduction, and then you have ChatGPT writing his thesis. Frank Wolf, and I don't know what I'm looking for here. Actually, what is the next main question? Learnability of MNL. Our model is Cascade. So what is the main problem that we are dealing with here? And well, it gets deep inside identifiability. And what is the other paper? Click-based MNL. This paper is also quite huge. So what is the title? Click-based MNL. Uh, uh, Alright, click-based MNL. Actually, I saw WIFC. So okay, that's something here. The click-based.
The click-based MNL, multinomial logic, model described in the paper click-based MNL.pdf presents a two-stage stochastic model for customer behavior in e-commerce and explicitly allows for multiple item clicks. Here's the
We're given a sort of configuration probability that item is clicked. Preference weight using to describe how attractive an item is once it is in the consideration. Selling price used to calculate. So this is actually what Negin also used. The process is registered to customer for each item independently with probability lambda I choose a stage. Okay, once you are chosen, the probability of that you are being exactly one item. Oh, then purchase. Okay, I like that. No problem with it. Then the purchase probability for item I is lambda I times this probability. Yeah, y. And the expectation is over the consideration set. Okay, but where is the MNL part? Multiple clicks? Yes, customers can click on. Independent Bernoulli trials? Okay. How is that related to our case? Our case, what is the problem? We have two groups of items. We have two relevance vector for each of them, and which can be their WI, and then we want to learn that model, which means we want to find RA and RB. Okay. Let's talk about this paper. So what is our project? Okay, our project. Okay, you cannot just learn it. We want to come up with an algorithm that learns this thing well. That's what we want to do, because we are doing 1,000 iteration. What is the genius in our method? Like, okay, you can solve this problem. First of all, we are not solving our current problem very good. The likelihoods are not great. Yeah, you can write mathematics and everything, but we want to compare it with other results, and we want to come up with an algorithm that does this clustering sufficiently, hopefully in a polynomial time or whatever. Yeah, that will be our achievement. Or that we give to other people to help them. I mean, the form of polynomial time estimation for this problem showing that optimal expected revenue can be efficiently approved with a negative accuracy. Novel technical ideas, including enumerations, inequalities may be acquired. Oh, they also work with Alibaba, which is great. Which so they are working with MNL. So it's just 1%. AOUAD. Wow. Only. Well, none of them is in Alibaba. Click-based MNL will be. Yeah, where are they getting their data? Alibaba. Assortment optimization, right? K latent user types is with alpha K. So they are mixture weight alpha K. They are K latent of them. It seems it is beta K. Yes. Okay. Alpha K is probably belonging to. So this paper only allows for one clade. Oh, you don't need to know K in advance. Consumer Nielsen consumer panel data. They all have data. Data. Alright. Let's go. For every So we have identify. Wait, this is too much math. I'm not gonna get into them right now. Mhm. True moment, empirical moments, and estimated. SRFW is doing great. So you wanna come up with an approach and then say other approaches. How does other approaches work for your, what is that? Average distance to closest through Q. Yogurt. Alright, that's good. I read this 100-page. Honestly, I am not interested in talking about NP problems, NP hard, unless it makes sense to me. I don't get it. What do I care about? So I like to know Ehsan's opinion on this actually. These theoretical things. So okay, fuck them. Alright, my last note. I wanna know, okay, we have this algorithm, we compute these R's, what is Ehsan caring about? Well, somebody may say, okay, your algorithm to find these R's are not efficient. I may want to make it a bit better, but I don't want it to be the focus. I don't want the optimization of this algorithm be the focus. I don't want it. No, I don't think. But what is it? How can it help us from e-commerce point of view? Let's assume we have the best algorithm for finding these values. Now we put it like we separate these categories of products, and user comes. Is it the best thing? Or I say, Ehsan also mentioned that, all right, this you are assuming that this list of product is constant. Now what can we make to change it, to make it and they don't have clicks. If they don't have clicks, identifiability of these products can be difficult. The model learnability. So we may want to come up with a new model that describes eBay's dataset. That's it, I think. Well, yeah, I have to go. Namaste.